We're going to continue with chapter 5. This is section 5-4, Rational Exponents. The first thing I want you to remember is that by rational, I mean fractions. So over here, just remember that rational means fractional. Or fraction exponent, okay? So I'll come back to that in a minute. So our objective is to simplify expressions with rational or fractional exponents. Remember, it's the same thing. Our main rule is this. Pay attention in this part because this is probably the most important chunk of this lesson. If we have the nth root of x, any base, in this case it's x, to the power m, we're able to rewrite it as a fraction like this. So notice that the exponent goes on the numerator and the root goes in the denominator. For instance, if I give you the cubic root of 4 squared, I can just say, using this rule, remember the base stays the same. The exponent inside goes as the numerator, and the root goes in the denominator. So I can say that the cubic root of 4 squared is the same thing as saying 4 raised to the 2/3. Okay, so this is what we're going to be dealing with today. We're going to see examples in which this comes in handy. For instance, and this is very poorly written. Let me fix this. I actually want to erase this because that just looks like I'm saying 6. Let's say that I give you 216 raised to the 1/3. How could I go back from this to this? What does this really mean? All it means is I'm going to write a radical symbol. I'm going to have, remember, the n is the index. So it's the cubic root of 216 to the power of 1. But I don't really have to put that 1 there, right? And you know that it's imaginary. So now I start thinking, how can I solve this? And let's go ahead and do a factor tree for 16. I happen to know that this is 6 times 36, and this is 6 times 6. So we know that over here we have the cubic root of 6 cubed, and as we have learned, the exponent cancels, matches the index, so we can get rid of the radical. So my answer is 6. Okay, so let's move on to the next example. How could I rewrite this? Remember, I'm going to use this rule. So I have it written in rational exponent form, so I have it written like this, and I want to make it look like this. How can I do that? It's actually very easy. My denominator tells me what type of root it's going to be. In this case, it's going to be a square root. Remember, I don't need to write that, but I'm just doing it to show you. I have 7 to the 1st power. I don't need to write that either. And as we have learned, we can just go ahead and multiply square roots if the indexes match. And what's the square root of 49? The answer is just 7. So we have two examples here that we're required to do. What it's asking us, what is being asked here is that we rewrite this using radical form. That means that we're going to need some type of radical, right? And the question is, where does everything go so that these two things are similar? Again, using the previous set of notes, from example 1, we know that the base is going to stay the same. The denominator, remember that the rule is x square root of x n to the m equals x to the m over n. The denominator is going to be my root. So in this case, the denominator is 7. The numerator, the one on top, is my 3. So the correct answer is this. This one is going to take us a little bit longer because we have to figure out what fraction gives us 3.5. So after a little bit of thinking, you go ahead and say, well, 5 divided by 2, 4 divided by 2 is 2, 6 divided by 2 is 3, 8 divided by 2 is 4. So you know that it has to be between 6 and 8. So the correct answer is 7 over 2. Because, you know, $7 by 2 people is 3.5, but one of them has to be negative. So this right here becomes y to the negative 7 over 2. And now we want to turn this into a radical. However, in a previous lesson we learned that we are not allowed to have negative exponents, and that whatever was with the negative exponent, we sent him down there. Remember, bad things go down there. So my correct answer for this is this, and then from here we go ahead and use the rule. Again, the denominator is the root, so it stays as a 2, and the y, it's a 7th. Y to the 7th, because again, my numerator is my exponent inside. Okay? The next problem tells us to go the other way around. So we want to work backwards now. So if I have a to the square root of a to the 5th, that's going to be a very simple using this rule. Now, notice that there's a 2 here. The base stays the same. The exponent inside is the numerator, and the index, remember index has the index has a d, is my denominator. That's how you can remember. Denominator. So my index is my denominator, and that's all you have to do. Let's take a look at the next one. Let's say that we have b. Notice that this b outside can be easily moved inside. There's no problem with that. There's absolutely no difference between this right here and this right here. So using the same rule, we can say that this is b, exponent is the numerator, and the index is the denominator. Again, I'm emphasizing that so that you can remember. And that's all we do, guys.